Welcome again to Code Tab. In this series of videos, we are solving algorithm challenges, and this is problem 17 from Project Euler.net. The name of the problem is Number Letter Counts. The description is the following. If the numbers 1 to 5 are written out in words 1, 2, 3, 4, 5, then there are 3 plus 3 plus 5 plus 4 plus 4 equal to 19 letters used in total. If all the numbers from 1 to 1000, inclusive, were written out in words, how many letters would it be used? There is a note here which states do not count space or hyphens. For example, 342 is like 342 contains 23 letters, and 115 is just 20 letters. The use of and should be compliant with the British usage, right? So this problem is not difficult at all. It's just very annoying to go through all the possibilities and count these words, right? So it's just lengthy to write. I will go through it, but there is no challenge here. It's just summing this up and just combining these words to according to the letters of the numbers, right? So let's just go for it. First, let's just create here problem 17. Let's just add our Python file, problem 17. The first thing I will do is to create a dictionary to store how many letters some key numbers here have that I will later combine it with others in order to sum all of them, right? So I'm going to call this letters dictionary, in which the key here is going to be a number such as 1, and the value is going to be, I can store it as a string, for example, 1, right? I can do the same thing here for several key numbers. So I'll just write them down, and later I'll just accelerate the video here. So here we go, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 19, and then we reach 20. From here onwards, I'm not going to just write 21, 22, nothing of the sort. I'm just going to go for the tens now, right? So 30, oopsie, right? So 40, 40, 50, 60, 70, 80, and 90. I will stop at 90, okay? So I have this dictionary of letters here for all of these letters in the numbers from 1 to 20, and then all the tens from 20 onwards, which is like 20, 30, 40, and so on, right? What am I going to do with this? I intend to count the letters by checking for each number, right? I'll create a function then called like count letters number. Given one number, it will return how many letters this number has, right? So this function should count the number of letters a number has. So this is the given number, and this is the number of letters. What I'm going to do then is to create a number string, right, starting empty. And then I will check how to combine the words in the dictionary here in order to deal with that, right? So, well, the first thing is if this number is bigger than 100, then the number will have 3 parts. We'll have the hundreds parts, the tens parts, and the unit parts. So hundreds, then it's going to be this part. How many hundreds are there? Right, and the rest, then I will have, it's just going to be like the remainder, right, of this division. So I'm just dividing the number by 100. So I get the hundreds parts and the rest part. Then I can add to my numbers dictionary here how many letters the hundredths part have. So this one will receive this plus our letter dictionary, given the hundredths part, plus the word 100, right? If my n is bigger than 0, I better add also here a word and, right? For situations which is like 125, right? 278. So always there will be an and. The only exception when there is not going to be an and is there is no remainder. So for words such as 100, 200, 300, and so on. So they should deal with that, right? We're not counting spaces here, so I'm not putting spaces. And here I also need to check if we are in the tens part, right? So if we are in the tens part, we also need to add this part. However, we just do that for numbers bigger than 20. So if our number is bigger than 20, we then get the tens part. So it's the same calculation here. We divide it by 10, and we get the n part, which is this here, the mod by 10, okay? And then we just add to our number string here in our letter dictionary how many tens that we have. I just multiply by 10 because that's how I represent it here, right? That should do it. In the end, if I still have a remainder, right? So if I still have a number that's bigger than 0, it certainly has to be from 1 to 20. So I can just add them here to my number, okay? And I shall return then, as a result, since I just have strings here, I just calculate the length of that, how many numbers are there. This should do it. One question that shall arise is why there is no and here. It is because like when you are representing numbers from 20 to 100, there is no and inside. So for example, 75, there is no and there. Since they note here that hyphens do not count, so I'm taking them out as well. I'm not calculating them. This should do the trick from numbers from 1 to 999. However, they also mention that 1000 is included, right? So I'm just going to add an exception here. If n is equal to 1000, I'm going to return the len of 1000, okay? And if it's bigger than 1000, I'm not caring here. Right, so let's test our function first. So count letters number. I'm going to give some of the numbers they mention here. So for example, 342, right? Let's see what we get here. And it gives us 23, which is correct. Let's get a different number. 115 shall give us 20, which is correct as well. To solve the main problem, then we're just going to have to sum all of this. Okay, so we just go from 1 in range to 1 to 1001, right? And then we count the count letters number for that number, right? Or better saying here, we can just do this in a list of comprehension. So we can just do like this, print the sum. That should do it. Let's see what we get here as a result. Whoopa, we have a problem. We have a problem that states that the key error is 100. So if we have the number 100, that is a problem. And I know what it is because here should also include the word 100, right? Otherwise it was going here in our exception. This is not right. Let's try again. Okay, now we have a result. Okay, so this was the problem here. It has to include 100 in that first condition. Okay, so we have this result here. I hope this result is right. If not, we're gonna have to debug this a lot. Let's give it a try. 3, 2, 1. Yes, it is. So we have the right solution to this problem. This problem is like this, very simple, just annoying to type all of this and check these conditions. Thank you so much if you watched until now. I hope you liked this problem, and if you really liked the video, please like, share, subscribe, turn on the notification bell. That helps a lot. And I see you on the next video. Bye bye.